This is pre-calc video on 2.2, solving quadratic equations by completing the square. And we've got 4 steps to solve quadratics by completing the square. And I've got my first problem. All right, step 1. Write in the form x squared plus bx equals c. So that means that your x squared and your x term have to be on the left-hand side of the equal sign, and your constant term should be on the right-hand side of the equal sign. For my problem number 1, it's already set up that way. I don't have to do anything. Step 2, add b over 2 squared to both sides. So b in this case is -2. This is the amount that I'm going to add to both sides. So I'm going to take -2, divide it in 2, and square it. So that is going to be -2 divided by 2 is -1, squared is +1. I'm going to add 1 to both sides of the equal sign. On the left-hand side, they are not like terms. On the right-hand side, 12 plus 1 is 13. All right, now, by doing that, what you've done is you've set your trinomial to become a perfect square trinomial. So one of the factoring methods that we had to review in the factoring review is how to factor perfect square trinomials, where the first term is a perfect square, the last term is a perfect square, and the term in the middle is equal to the product of those square roots times 2. Okay, and that's what we've got here. So to factor that, I'm just going to put the square root of the first thing, the sine of the middle thing, and the square root of the last thing squared. All right, now we're going to use the same method we did in the previous work to solve it like it was square root. So my square is already isolated. I'm going to take the square root of both sides. Radical 13 cannot be simplified. I'm just going to add 1 to both sides. All right, that's your answer, and that is the form that I need to see it in. No decimals, simplest fraction, simplest radical form. All right, problem number 2. All right, the first step is to put your x squared and your x term on the left and your constant term on the right. So I'm going to start by adding 1 to put that 1 to the other side of the equal sign. And then I'm going to take half of b squared. Our b is the same number as it was in the last problem. So half of -2 is -1. -1 squared is +1. So I'm going to add 1 to both sides. Add 1 to both sides. So on the left, I'm just bringing that 1 down. On the right, 1 plus 1 is 2. Again, this is a perfect square trinomial. Square root of the first thing, sine of the middle thing, square root of the last thing, squared. Now that it's written as a square, I can use the square root method to solve it. Square root both sides. And then add 1. Problem 3. All right. All right, I guess I'm still recording. Okay. I'm going to skip problem 3, which was on the screen a minute ago. I don't want that one. So I'm going to skip to problem 4. All right. So first step is to put my 104 on the other side of the equal sign. All right, this time b is 20, so I'm going to take half of 20 squared. Half of 20 is 10. 10 squared is 100. I'm going to add 100 to both sides. All right, so just in case you didn't see what I just did, I added 100 to both sides. All right, now I'm going to factor the left. It is a perfect square trinomial, the square root of the first thing, the sine of the middle thing, the square root of the last thing, squared. I'm going to take the square root of both sides. Now on the right, I'm going to simplify that radical before I go any further. That's a complex number. You know what? We started off this section by saying we're only interested in real solutions. So since we've got a square root of a negative, we're just going to say that this has no solution. It would have a solution with an I in it, but it's not real. For the purpose of this section, we're not studying imaginary solutions. We'll study that a little later in the year. All right, that's it for this video.